Welcome back. We're on number 2 of the 8-7 notes. We're learning to identify a difference of perfect squares and how to factor it. Well, first of all, is this a difference of squares? Well, it is a binomial, which tells me maybe it is a difference of perfect squares. It's 2 chunks long. It has a subtraction sign in the middle. It has a perfect square in the front and back. If I look at my multiplication chart, both 100 and 49 are in the yellow, so that tells me they're squares. And a squared is in fact a square. So how do we show work? Well, the square root of 100 is 10. The square root of a squared is a. The square root of 49 is 7. That in purple is the work I'm wanting to see. Set up your 2 sets of parentheses. We have 10 times 10 is the 100 in the front. We have a times a, that also gives me that a squared in the front. We have 7 times 7, that would give me the 49 in the back. And we know we're going to have opposite signs because conjugate binomials, when multiplied out, give us a difference of squares. Let's keep going on number 3 on the notes. So we have 25x squared minus 81. Well, is it a difference of perfect squares? Let's see. Is it a binomial? Check. Does it have a subtraction sign in the middle? Check. Is 25 and 81 perfect squares? Check. So let's go ahead and give this a roll. The square root of 25 is 5. The square root of x squared is x. The square root of 81 is 9. So the difference of perfect squares has different signs. A difference of perfect squares has different signs. 5x times another 5x gives me that 25x squared in the front. And 9 times 9 gives me that 81 in the back. Looking good. Next one. I'm looking for, is this a difference of squares? It's a binomial. Has a subtraction sign in the middle. 1 is in fact a perfect square, and so is 16. We can reference our multiplication chart. There's 1, there's 16. So let's go ahead and get started. I know the square root of 16 is 4. The square root of x squared is x. And the square root of 1 is 1. So a difference of perfect squares has different signs. That is 4, not 8. It's 4. 4x times 4x is 16x squared. And 1 times 1 gives me that 1 in the back. And number 5. We know that it is a difference of squares. How can we tell? It's a binomial, subtraction sign, perfect squares front and back. What gives me the 9b squared? 3b. 3b times 3b is 9b squared. And 10 times 10 is the 100. This in purple is what I'm looking for on your work. Please show work. Thank you. Now you guys should pause the video and do 6, 7, and 8 on your own. So go ahead and pause the video and do 6, 7, and 8 on your own. Go for it. Okay, so let's do question number 6. Here we go. And again, we're continuing with the 8-7 notes. So we're on 6, 7, and 8. 6, 36, a squared minus 121. 7 is 81, x squared minus 49. And 8 is 121 n squared minus 4. So let's see what we got. Do they all have a subtraction sign? Yes. Are they all binomials? Yes. Bi means they're 2 pieces long. Perfect square? Yep. Perfect square? A squared is a square. So let's show the work that's needed to get points. 36, the square root of 36 is 6. Square root of a squared is a. The square root of 121 is 11. A difference of perfect squares has different signs. Beautiful. Let's do the next one. I can see it's a difference of squares. It's a binomial. So we know that 9 times 9 gives me 81. X times x gives me x squared. 7 times 7 gives me 49. Let's set up our parentheses. We have 9x, 9x. Those multiply to give me the 81x squared, and 7 times 7 is the 49. Let's try the last one. Eleven times 11 gives me 121. N times n gives me n squared. And this last one is 2. So we have 11n, 11n. Those multiply together to give me that 121n squared plus or minus 2. And if you were like, does this really multiply to give me that binomial? Well, go ahead and FOIL it out. Front, outer, inner, and last. Front, outer, inner, and last. We can see that our middle terms cancel, and we're left with 121x squared minus 4. If you're ever hesitant to go, I don't know if that's the answer, well, go ahead and multiply it out. And if the final thing that you get is what the original showed, you know you did it right. Good job. We're going to go on to question 9, which we can see clearly on our notes is not a difference of perfect squares. It's not a binomial. What do we do? Well, that's coming up next.